Welcome to another edition of Math for Novices. In this edition, we try to evaluate this indefinite integral, which is the integral of 1 by root over a square plus x square, and show that this is equal to sine h inverse x by a plus some constant. Now, to show that the indefinite integral of a quantity is the given quantity, one way to show is to show that the derivative of this quantity is equal to the integrand here, and that will be the method that we will be trying to use. Now, it is not difficult to see that sin hx is a 1 onto function from the set of real numbers to itself. So, sin h from R to R is a bijection. So, note that as x goes to plus infinity, e power x goes to plus infinity, e power minus x goes to 0. So, sin h x goes to plus infinity, and as x goes to minus infinity, e power x goes to 0, but e power minus x goes to plus infinity. We have a minus before that, so sin hx goes to minus infinity. And what is the derivative of sin hx? That is e power x plus e power minus x by 2, and that is always greater than 0. So, sin hx is an increasing function, in fact a strictly increasing function, which goes to minus infinity as x goes to minus infinity and goes to plus infinity as x goes to plus infinity. So, it is a 1 function from R to R, and therefore it is a bijection. This quantity e power x plus e power minus x by 2 is called cos hx, and that is another very important function, another very hyperbolic function. So, sin h is sine hyperbolic, whereas cos h is the cos hyperbolic function. Now, let us look at how do you obtain the derivative of sin h inverse x. That task is not very hard, but let us do it carefully. First, let us think of it in general terms. So, if we are looking at f inverse of fx, that is equal to x. That is by the definition of the inverse function. The derivative of this by the chain rule becomes f inverse prime at the point fx into f prime x, and that is equal to 1. And this gives us f inverse prime at the point fx is 1 by f prime x. So, we can call fx as y, and then x is f inverse y, and therefore this becomes the derivative of the inverse function at the point y is 1 by the derivative of the original function at the point f inverse y. Now, we will apply this to sin h inverse x. The derivative of sin h inverse at the point x is equal to 1 by the derivative of sin h evaluated at the point sin h inverse x. So, this is 1 by cos h evaluated at the point sin h inverse x. So, that is the derivative of sin h inverse x. Now, we have to simplify this. So, let us try to evaluate cos h square x minus sin h square x. From the definition, this is e power x plus e power minus x by 2 whole square minus e power x minus e power minus x by 2 whole square. So, cos h is e power x plus e power minus x by 2, and sin h is e power x minus e power minus x by 2. Now, if we simplify this becomes e power 2x plus e power minus 2x, and 2 into e power x into e power minus x gives us just 2. So, plus 2 divided by 4 minus e power 2x plus e power minus 2x, now minus 2 divided by 4. So, you see that after cancellation, what you are left with is 4 by 4, which is equal to 1. So, cos hyperbolic square x minus sine hyperbolic square x is equal to 1, and this would be the result that we will be using. Now, we will rewrite this as using this inequality as 1 by, first of all, we'll write this as cos h square evaluated at sine h inverse x, and then write cos h square x in terms of 1 plus sine h square x. So, this would become 1 by square root of 1 plus sine h square sine h inverse x, and so sine h and sine h inverse, this would cancel, and this would give us 1 by root over 1 plus x. So, what we have obtained is that the derivative of sine h inverse x is 1 by square root of 1 plus x square. Another way of writing this is that the indefinite integral of root over 1 plus x square is sine h inverse x plus some constant c. And now it is the straightforward to obtain the given integral. So, first we write this as 1 by a integral dx by root over 1 plus x by a whole square, and then let u be equal to x by a, and then du is equal to dx by a. So, this becomes integral du divided by 1 plus u square, which is by this formula sine h inverse u plus c, but c is an integration constant and u is x by a. So, we get sine h inverse by a plus. So, we have been able to integrate dx by root over a square plus x square in terms of the inverse of the hyperbolic sine function. Thank you.